वो जो एक ऑडियो में गड़बड़ हो रही थी ना, हमें वो खत्म हो गई है। थैंक यू।
अब वो जाहिर है दो सिस्टम ऑन थे।
गड़बड़ हो रही थी ना, हमें वो खत्म हो गई है। थैंक यू।
जी।
अब वो गड़बड़ हो रही थी ना, हमें वो खत्म हो गई है। थैंक यू। आज आप देखें फिर Bismillahirrahmanirrahim. In the name of Allah, the most gracious and the most merciful. Ladies and gentlemen, Assalamu alaikum and good afternoon from Pakistan Society of Civil Engineers based in Lahore, Pakistan. A very warm welcome to all the participants who have joined us on Facebook. This is lecture number 48, organized under the auspices of Pakistan Society of Civil Engineers. Today's topic is tall buildings and geotechnical aspects. Our guest speaker is Engineer Sohail Kibriya. Before I move to introduce Engineer Sohail Kibriya, the rules of the webinar that I'm supposed to, it's my duty and responsibility to spell out the rules here. First one, registered participants for CPD points have to appear live on webcam. However, for the ladies, there is an exception. If they wish, they can cover their face while appearing live on webcam. During the lecture, microphone of all participants except that of speaker shall remain in mute position. There will be a question-answer session of 20 minutes at the end of the lecture. However, the speaker has permitted questions to be asked during the course of lecture slide by slide. But kindly make a note, during the lecture, questions can be asked by typing the text in the chat box only. However, during the 20-minute question-answer session, you will have the privilege for asking the question using your microphones. Participants on Facebook only have option, they have to type their question. Participants on the Facebook have only one option. They have to type their questions in the chat box. I would request all the participants to please mute their microphones and they shall remain in a mute position. Only the microphone of speaker, though anybody who is speaking, his microphone shall remain in an unmute position. Thank you. Now, these are the rules of the webinar. Now, the introduction of the guest. Mr. Sohail Kibriya is no stranger for Pakistan Society of Civil Engineers. He is not only the founder member of Pakistan Society of Civil Engineers, but a regular speaker from our platform. He is an eminent geotechnical engineer of Pakistan, having more than 40 years of teaching, research, and practicing experience in Pakistan and abroad. Mr. Kibriya obtained his bachelor's degree in civil engineering in 1980 and master's degree in geotechnical engineering in 2004, both from UET Lahore. In between, he studied at Lahore University of Management Sciences, commonly known as LUMS, and Pakistan Institute of Management, commonly known as PIM, to earn a handful of diplomas. He has acquired a series of trainings and attended a host of seminars, workshops, conferences in Pakistan, Malaysia, South Korea, Nepal, UK, France, UAE, Oman, etc., as a part of continuing professional development. He has gained significantly rich geotechnical experience of working on diverse engineering projects, including nuclear power plants, irrigation and hydraulic works, dams, sewerage and drainage works, hydropower projects, water supply, highways, motorways, buildings, airports, and bridges. He has carried out professional work in Pakistan, Saudi Arabia, Republic of Dominica, Afghanistan, Oman, UAE, Qatar, UK, France, China, and Ethiopia. Mr. Kibriya started his professional career as lecturer in soil mechanics lab at UET Lahore. And then he joined NESPARC as a junior engineer, from where he retired as vice president. Today, he's still serving NESPARC as head of research and development cell. Mr. Kibriya is an author of over 70 research papers, which have been printed and presented in the conferences, seminars in Pakistan and abroad. He is the visiting faculty of FAST University Lahore, adjunct faculty of MCE Risalpur, and member board of studies of University of Central Punjab. Suhail Kibriya is a member of following societies, Pakistan and institutions: Pakistan Engineering Council, Institution of Engineers Pakistan, Pakistan Geotechnical Engineering Society, American Society of Civil Engineers, Pakistan Engineering Council, Congress, International Society of Soil Mechanics and Geotechnical Engineering, and of course, Pakistan Society of Civil Engineers. Mr. Kibriya has main interest in soil dynamics, ground improvement, foundation engineering, landslides, problematic soils, field and laboratory practices. Besides high geotechnical capability, he has demonstrated outstanding project management skills too. So, gentlemen, today's topic is tall buildings and geotechnical aspects. So over to you, Suhail Kibriya. Please start your lecture. Thank you.
Thank you very much for a very detailed introduction. I'm just going to share my screen. So, Bismillahirrahmanirrahim. Tall buildings and geotechnical engineering aspects. You know, in tall buildings, the aspects which dominate are structural engineering and architecture. So geotechnical is a part of that, but that's very important too. So,
Suhail, just interruption for a second. Actually, as I was making the introduction, so I just realized now that we are joined today by Tatiana Turanda. She was our speaker this year also a few months back. So Tatiana, a very warm welcome to you from Pakistan Society of Civil Engineers. And thank you for coming today. Please go ahead.
Thank you. Thank you, Professor Tatiana. I sent her invitation to yesterday. Thank you very much to be here from Belarus. That flow of that various topics for discussion today would be, first, I'll start with general overview, giving general information about the tall buildings, their classification systems and this and that, and the role of geotechnical structure and architecture in that. Then I'll give you some glimpses of the tall buildings which have been constructed in the world, followed by some tall buildings which are present now and coming up in Pakistan too. Then I'll have some details about the foundations and soils, about 3 notable buildings in the world, and some innovative considerations will be given in the end. So you see, we think that tall buildings are the future, and the space is diminishing on this planet Earth, you see, with more inhabitation and more consumption. So we have to think going up or going below the ground too. So today we are talking about going up, you see, in the form of tall buildings. Whether we have to address the housing projects, you see, in Pakistan or in some other countries, whether for low-cost purpose or whether for people who can afford, affluent people, there have to be tall buildings of different types, you see, to be designed and constructed in different manners. So, as I've told earlier, it is the requirement, you see, of the increase in population which has put pressure on the resources requiring more accommodation for people, and of course, more parking places. So of course, taller buildings would allow building, you see, to some bigger heights with the large accommodation of spaces, as well as allowing deeper basements to be constructed. It is true that to the developers, it gives a lot of profitability, you see, while planning such building, you see, and we see that even in our local market, there are so many ads about the tall buildings, you see, relatively tall buildings. But as engineers, as professionals, we see that there are a host of challenges too, which we have to cater for while going for the tall buildings. So they stem out from the requirements which have to be met for stability, for safety, of course. Cost is also a component, and we don't want that they should have some risk of subsidence, and we have to look at the groundwater problems, the seepage problems too, and if they are constructed in areas which are having high seismicities, etc., and if there are scenarios like blasts because of any reason or high winds, the tall buildings have to withstand all of these, you see, phenomenon, all of these factors in a safe manner. So in order to ensure this, as a geotechnical engineer, I would say that the importance of in-depth ground studies or geotechnical investigations by sound geotechnical professionals with proper equipment and proper testing is more than in ordinary structures or in ordinary works. Here we have to be more alert, and we have to be more cautious. So we just have some views of tall buildings in the world. First of all, this is Burj Khalifa, which is, you see, rising out, you see, of the clouds and standing out of the other buildings located in the vicinity. It's even, you see, up to its spire, it's quite high. You can see the conical part on the top. Some of you might have seen this. Just a small comparison of a few tall buildings in the world. So as you can see, just a minute, let me shift this, just a minute. I have to go back. I have to shift some part of the screen. Yeah, now it is clear for me. You can see out of these 6 images, 3 are of some tall buildings in USA. To the leftmost is the Third West, located in the 57th Street in New York. Second is the Central Park Tower in New York. One World Trade Center, New York. New York was one main place in the 20th century, you see, which was having so many tall buildings, and there was a trend of constructing tall buildings there. And then you see, fourth one is in China, Wuhan Greenland Center, and then Burj Khalifa, and finally under construction, Jeddah Tower. You can notice their relative heights too, you see. You can see that Jeddah Tower, of course, will be touching something like 1 kilometer, including its conical part. And the Burj Khalifa at the moment is 2,717 feet high, and others you see the comparison over different times. But the interesting trend is that from USA, the trend of constructing tall buildings has shifted towards Asia and towards Middle Eastern region. Just a minute. Well, it's not moving. I'm trying to fix it. Yeah. Just a minute. Here you see the sky. Yeah.
Sohail, while you fix the settings at your end, we have a question from Javeria Ahmed.
Yeah.
We have a question from Javeria Ahmed. She's asking,
Yeah,
it is sort of a political question anyhow, sir. Wouldn't tall buildings make easy targets for terrorist activities? I think she's referring to the Twin Towers, maybe.
You see, it's a political question. I'm a geotechnical engineer. Okay, so this is my answer. Let's not discuss such, you see, intriguing topics here. Let's talk about engineering, about, you see, a little of architecture. I can also discuss a little of structural engineering, but mainly geotechnical engineering. Okay. Look, have a look at the Chicago skyline. You see, looks beautiful. Toronto. So this trend you see in different countries of the world, and we all who have visited Dubai, we know the beautiful skyline of tall buildings there. By the sea, you see by the seashore, another view from the backside. The first one was from the seaside. This is Qatar. Qatar is a very rich, affluent country, and you can see the type of architecture. It is, you see, very luxurious, you can say. Exaggerations, and you see expensive works, and you see lot of architecture. You see, it's not plain engineering. And New York's, Shanghai, and in London, in Europe also, the trend of tall buildings, you see, because of the space limitation is now going in. And you see, you can see in the background the old part of London with the traditional buildings and new buildings, you see, which are high buildings, they are coming up. So let's discuss now that what tall buildings really are. Just a minute. Yeah. So tall buildings have been given different names. They're called high-rise too and skyscrapers too. So it's the same thing. Now let's talk about how people and experts think about them. That what is the notion about the tall buildings? One notion is that the ones in which most occupants have to use lifts and elevators to reach to the upper levels. So this is a definition given by Craighead in 2009. So this is understandable. You imagine that if there's a 60-story building in Lahore, it will not be possible to climb the staircases. So a taller building using lifts and staircases. Another classification is that those buildings which have more than 40 stories, they are essentially tall buildings. And another definition is that building which is slender. You see in the plan, if you look, you see their width is quite less compared to their length. So that makes a slender building. And another interesting definition is that the building which really stand out in the city, you see, as a prominent tall building, as I've shown you many images, and some of the buildings are really standing out in the city landscape. Somehow this gives a bit trouble. So there's a council in the world for tall buildings and urban habitat, CTBUH. Council for Tall Buildings and Urban Habitat. They have a very good classification of their own. They say that the buildings which fall in the range 200 to 300 meters, they are essentially tall. And the ones which are less than 200, they don't think that they're that tall. Then if the building height is from 300 to 600 meters, we may call them super tall according to this classification of CTBUH. And if the building height is more than 600 meters, then they are mega tall. So I think this is very interesting to know that there's a definition of tall, super tall, and mega tall. In 2016, I was checking the statistics. There were about 100 super tall and only 2 mega tall buildings. I mean, the buildings which were exceeding 600 meters in height were only two globally, worldwide. Okay. Now have a look at the early development. Modern tall buildings evolved in United States, and we see that the first signs appeared in Chicago back in 1880. So interestingly, it is in the post-industrial revolution era, which is said to be from 1760 to around 1840. So I think this is the economical fluency, I think, and more money coming out, you see, in addition to the space requirement and the creation of business centers in busy areas, that the trend of tall buildings came up back in 1880. So how were they? They used even load-bearing walls compared to the modern tall building. And then later, steel was started being used in New York, Philadelphia, and London. In the 20th century, in the last century, New York held the world record of the tall building. They had the maximum number of tall buildings. But now the trend has gone deep in Asia and in Middle East countries. What are the main, you can say, components or main parts from one consideration point of view? And that is foundations, one main part, main segment. Then other is the structure, the main structure, the facade. This is how some experts divide it. Then a lot of importance is given to the architectural renderings, the architectural works to give it beauty from exterior and from interior, the finishes and everything. Then the importance is given to elevators and lifts and building services. Just a minute. Yeah. So very rough idea just to give you the component area, relative area and the cost. The footprint area in tall buildings is generally, according to the worldwide statistics, between 80 to 100% of the total site area. So a lot of the areas being consumed, you see in the cities, you see out of the total area. And the lettable area, which is the rentable area, is about 80% of the floor area. And the costs evaluated approximately by one investigator, Al-Musharraf. The architectural work, you see, on the average, a very big, you see, very big statement, a ballpark figure, on the basis of architecture, 40% money is spent on architectural work, 30% structural, mechanical, and electrical, and plumbing, MEP, 25%, and elevators, they consume 5%. You see, this is to give you an idea that how the cost is, you see, cost is involved. Now you see in this slide, you can see cost component given by Deng and Wu. Ground civil works cost 67%, 64%, and below works, below the ground, which includes basements and other maintenance works and foundation work, they require about 36%. And if deeper foundations have to be used, like piles, the cost of the pile would be about 7% of the cost of the total, you see, very rough figure. Basic maintenance works in earth and rock, 13%, and basement works, about 16%. Very interesting to find out. So this 7% cost, you see, for pile foundations, or 36% cost below the ground, this bears a lot of importance, you see, because the tall building or any other structure, after all, has to bear on the ground. So if there is a strong wind action, there's a lot of loading, if there's a lot of seismic activity, the building has to be held strong. Also, although sticking to the principles of economy, the design has to be such. Now, after having discussed and seen the tall buildings worldwide, some tall buildings of Pakistan. So Bahria Icon Tower in Karachi at 60th floor, including spire tip, the height is going to be 300 meters, 985 feet. So where does it fall? It falls within the tall building, 200 to 300 meters, at the boundary of the tall and super tall. So most of the buildings in Pakistan, which we call tall, are of course in the populous city. You see, where we have to have more business activity or where we have to have more accommodation, you see, as dictated by the city's development requirements. So we have the maximum number of tall buildings in Karachi, followed by Islamabad and in Lahore. In Lahore, you see why we have less tall building, because we have more open spaces available. Still the tendency culturally is to develop horizontally, but the trend is now coming up to go tall, and in the near future, in the coming years, I think we have to go up in Lahore too. So you see Habib Bank Plaza, 102 meters. It was constructed, you see, we all have seen it in 1963. Then it was the tallest building in Asia up to 68. and the tallest building in South Asia up to 1970. And in 2005, MCP Tower was constructed in Karachi, which surpassed the Sabi Bank Plaza, and it rose up to 116 meters. Then Ocean Towers eclipsed these; they're taller, 120 meters, and Barrier Icon, you see, then it surpassed all of these. A brief history of the Karachi Towers. Some tall buildings, comparisons of some tall building in Pakistan is just a small selection. A Barrier Icon Tower, 300 meters. Hotel Tower, you can see in Karachi, 260 meters. Chapel, Skymark, 210 meters. Dolmen Towers, 3 and 4, 200 meters. Hosheng Pearl, 160 meters. Bakht Tower, 145 meters. Now in Islamabad, you see, the tallest is the Centaurus Hotel, 116 meters. And Telecom Tower, 130 meters. Pakistan Telecom Engineering Company's tower. In Lahore, till now, we have Arfa Software Park, only 106 meters. Although population of Lahore is, you see, increasing, it is getting populous, you see, with every passage of year. So let us see how does it go. So many other tall buildings, you see, they're in construction right now. Have a look at the Barrier Icon Tower, the tallest in Karachi. The Bakht Tower in Karachi. Centaurus in Islamabad, you see there are 3 towers, 116 meters, and Pakistan Telecom Tower, you see in Islamabad, 113 meters. Lahore's Arfa Software Park, Arfa Kareem Software Park, 106 meters. So this is a brief detail, very brief detail according to the time which is available. Some brief information about the tall building. Let me put the scale down. Yeah, 12 tallest buildings as of 2015 in the world. You can have a look, you see. Very interesting to see that look at the usage, and also you see, at the type of construction which is employed in addition to the height and the number of floors. So the range from Burj Khalifa to Shanghai Tower to Makkah Royal, and you see World Trade Center in Taipei, Shanghai, and you see many of them, you see, starting from 1, 2, 3, they are, you can say, in this part of the world, the Middle East, then 4th one is in USA, then 5th, 6th, they are in Asia, 7th is in Asia, Kuala Lumpur again in Asia. So you see, in the 12 tall buildings now, as per the statistics of 2015, more are in Asia and Middle East than in USA, Canada, and Europe. So you see that the constructions have been ranging, you see, from steel and concrete to composite, and their uses, you see, have been office, residential, and hotel mixed uses, and some other buildings have been used only for offices. So this is how, according to the need, the development of tall buildings has taken place in the world. This is an interesting graph which shows you the relationship between the number of floors, the number of stories, and the building height. So according to the data, 3 types of usages: office, residential, and mixed use. They ultimately result into different building heights of the tall building. For the same number of floors, you can see from this figure, say you look at 150 stories. For the same number of stories, the office towers giving more headroom spaces are the tallest, and the residential towers, you see, to have more economy, you see, they are less in height for the same number of floors. This is interesting. This is how it is going. This is how the designs are prepared in the world for this. Now look at the trend of the tall buildings as per Parker and Wood, what he said in 2013. There has an increase in number, and many are under construction, so number is growing. And it's not a simple linear relationship, time or year versus the number. It's kind of, you see, a curvilinear. They're increasing, you see, in a curvilinear relationship. I think there is some sounds, some participant has to mute. He or she has to mute. Please mute your speaker. Increase in height, you see, as the development and more understanding is taking place, higher tall buildings, as I've shown you the trend. The tallest in Jeddah is coming up.
Excuse me, sir. Excuse me, sir.
Yeah, please.
Sir, slide नजर नहीं आ रहे. Slides नजर नहीं आ रहे.
आपको स्लाइड दिखाई नहीं दे रहे?
जी सर.
अच्छा, let us see. अब कुछ है, मैंने इसको मूव किया है. अब ठीक है?
So here we are on slide number 22. Which slide you are seeing on your screen?
I am at 30 and 31. Oh, आपने देखा ही नहीं उसके बाद? Oh.
I was a bit surprised that your talk and the slides are not in coordination.
So what I can do is I stop share and reshare. This is what I can do.
Please.
Okay, please. Just a minute.
I think it would be better if you can start from slide number 22 and go quickly up to the slide number 30. No need to repeat everything, but just go quick. No, Sohail, we can't see anything at the moment. It is blank. The sharing is not working.
Effective, okay.
Yeah, it's there.
It's there? It's a number.
It is slide number 32. It is slide number 32. But I would appreciate if you can start
Go
from
back.
22 again, but very quickly.
21. Can you see now that the slides are moving? Yeah.
It is
You
working.
saw up to this? You could see up to this?
Up to this, yeah. This is
Yes, sir.
okay.
अभी ठीक है, sir. अभी ठीक है.
Yeah, please,
okay.
Don't interfere. I am here to coordinate. Please,
okay.
Everybody, keep your microphone in mute position. So here I want to make a little announcement.
Yeah,
ladies and gentlemen, few people have typed their questions in the chat box. That's very encouraging. But while asking the question or typing the question, I would request, please follow the screen and the speaker. Don't ask the questions which speaker has not discussed yet. So I have noted 2 questions are there. That issue has not been discussed yet. So when the speaker, most probably, he will discuss what you have asked, then I will ask those questions. So ladies and gentlemen, please follow the screen and the speaker while you're asking the question. Thank you very much.
So on slide number 22, I will also request Tahir Saab that in the remaining part of the lecture, if you see that my screen is not moving, please do let me know. I will appreciate if it's done in time, because I have skipped 7 or 8 slides you see after slide number 21. No problem. Bahria, you can just see, I was just telling you the kind of tall buildings in Pakistan, ranging from Bahria Icon, which is 300 meters, to Habib Bank Plaza, which was built in 1963, and it was a very tall building at that time, and it was the tallest building in Asia. You see, we were having that kind of record, and up to 335 feet or 102 meters up to 1968. And in 2005, MCB Tower was constructed, and Habib Bank, which was higher than Habib Bank Plaza, it was 116 meters. Then Ocean Tower, which was 395 meters, and finally Bahria Icon Tower, which is the tallest. Over here you see different towers of Karachi, Islamabad, and Lahore. So Lahore is lagging behind, then followed by Islamabad and Karachi. You see, Karachi has the maximum number of tall buildings. Why this is so? You can think yourself. I told you earlier too, because the tall buildings are coming up as a result of the natural requirement. The requirements are that if there is more inhabitation, more population, more business requirement, and more space available, you see. So this is how the tall buildings trend continues. And you can see pictures of those who are not familiar or have not seen. I'm sure some people from Karachi, some participants from Karachi would also be here listening to me today. Bahria Icon Tower, Bakh Tower in Karachi, Centaurus of Islamabad, beautiful. Telecom Tower also of Islamabad, and this is 106 meter high Arfa Cream Software Park. Here I have shown you comparison. I think you're seeing this table now, slide number 29.
It's moving smoothly now. Thank you.
Okay, thank you. So just to give you a glimpse of 12 tallest buildings. Here you can see that most of them are in Asia or in Middle East now, on the basis of the statistics which I could collect up to 2015. And here you can see the material types which are used under the construction head: steel, concrete, or composite. And you can also look at the type of usage. So they have been used virtually for different purposes: office, residential, hotel, etc., etc. Most of them you see are in the Asian part and Middle Eastern part. Here I was showing you the relationship in this curve between the number of stories and building height. I was telling that according to different usages, for the same number of floors, the heights of these towers, on the basis of the statistics collected, they are different. For the same number of floors, the tallest towers are when they are constructed for office purposes, and you see taller towers which are least in height, they pertain to the residential towers for residential purposes. You can see here just an interesting, you see, information to you. So there has been a discussion on how the tall buildings are spreading. Parker and Wood gave their research finding that they are increasing in number, and we all perhaps have a feeling of that too. And they are increasing in height too. All the new towers which are coming up in different parts, they are taller. Many are taller than the previous ones. To change in location, now this is very interesting, from USA to Asia and Middle East. The reason behind mainly is, you see, the money market and the business market, you see. That is one big reason. Change in function from office to mixed use. This is another thing, not only offices, but mixed use, in which the hotel, the apartments, and the offices all have to be provided. And the material, construction material, structural material, from all steel to composite steel and concrete. This is the trend which is going on. What are the basic factors or key drivers which are requiring more tall buildings to be constructed? Because the land prices have increased and are increasing astronomically in the metropolitan areas, in the busy cities. So a smaller piece of land and taller construction and deeper construction gives good return to the investors. Notion of a building as a corporate branding, you see, this is another thing that I will say that I construct a tall building with this brand name. So it will, you see, be taken as a tall building by the name I give, and so my business activity will get, you see, more. Notion of a skyline dominated by tall buildings as global branding. Yeah, if one constructs a tall building in an area which is already having many tall buildings, so It will be a part of that skyline. That's part of the tall building area. So rapid urbanization, we all know. So to accommodate more population, more number of people, potential effects of climate change. Well, it's debatable too that tall buildings interfere with the climate also to some
So here
extent.
we have a
but-
question.
Yeah, please.
This question is from Javeria Ahmed. She is asking, size does not matter. How long or short the building is doesn't matter. It is how hard and strong it is matters.
Okay.
So why so much hype for tall buildings in Asia?
Why so much?
Hype for tall buildings in Asia. Why there is so much noise? You know, she's asking why there is so much noise for tall, long buildings in Asia.
You see, it is the, as I've told you, you can read this slide, you see, the answer is very qualitative, you see, because they are coming in Asia. So there are some driving reasons behind. You can find some answer out of the factors given here, you see. They are giving better return opportunity, you see, and the notion of a building to be used as a corporate building and more money is there. And you see, space limitation, of course. These are the natural reasons, you see. Here you see
Okay,
total.
let me
Yeah,
finish with
please.
the question. There are two more questions. This is from
Please,
Suleiman.
please.
This is from
Suleiman.
Suleiman
Okay.
Khan. He's saying high-rise buildings come with their own shortcomings, like prone to numerous more hazards than the relatively shorter buildings. What are your thoughts about it? And after that, there is one more.
Well, Suleiman, today's civil engineering caters for every kind of situation. You see, you spend more money, use that kind of technology which is befitting for that kind of work. So you can always control the hazard, you see. This is, you see, there's a trade-off between the amount that you spend and the mileage you take and the hazard that you see, control. Okay. So we cannot say that always that a short building you see that is always very safe and a tall building is always very dangerous or very hazardous. Had this been the situation, the taller buildings would have been abandoned to be constructed or planned. Gee, next.
This is, I think, just a comment from Ayla Bahid. She is saying, I think it's because of land. High-rise buildings usually do not need much of a land. So this is just a comment. You can continue, please.
Very good, Ayla. I think you are thinking and you are listening also with concentration. So these things are have already been told, and you're repeating this. Very good for other listeners to again listen to your good comment. Total number of buildings in excess of 300-meter height, based on the data of the Council for Tall Buildings and Urban Habitation. You can see the data is up to year 2020. The hatch line shows that some of them are under construction and they are expected to be like this, you see. But you see the trend. It is, you see a trend which is increasing, you see, in a curvilinear manner. You see kind of exponential, you can see. So this is how the trend is going. If you look just 10 years back, in 2010, only 52 reached the mark more than 300 meters. And it is about 4 times, you see, in 10 years. So this is, you see, remarkable. So this is a trend. So another relationship on the basis of study that the mass of the building and the number of stories based on the brace tube steel and diagrid steel, you see, not much difference, you see, as it has been shown here. But it gives a feeler, you see, for preliminary estimations, etc., because sometimes the preliminary estimation of the foundation types, you see, that how much load, how many stories, you see, this is the ground material type, this kind of soil or rock is there. So this kind of data is very helpful. Here in this slide, I show you one very interesting detail is the limit to the height. Considering only the foundation limitations. Now, if a maximum feasible pressure, say 5 MPa, which amounts to 5,000 kPa, which means something around about 50 tons per square foot, can be considered for a tall building, place or mat. It's very high pressure. This is possible only when we have a very sound material underneath. And the type of the foundation material has also to match with this kind of load and pressure, that it doesn't get crushed. So with an average loading of only 10 kPa per floor, I think there are structural engineers also sitting here. They will say that for the sake of estimation, this is a good way. The 10 kPa per floor, we say, just estimate, and the limit would be about 500 floors for this kind of loading situation. So you see, this is how the number of floors and the ground condition and the foundation type, they are interrelated. So this corresponds to a height of about 2,000 meters or 2 kilometers, giving a margin of a provision of 4 meters per floor. बड़ी ये वाइल्ड तरीके से आपको मैंने बताया, बड़े खुली सी बात की है, लेकिन आप देखें कि ये इस तरह है, ठीक है ना जी। अभी तो आपका जद्दा टावर जो है, this will be attaining a height of 1 kilometer. So I'm talking of 2 kilometers. Just to give you an example, thinking process में डालिए, the things of the foundations are not, I mean, isolated from the superstructure and the loading and architecture. It also depends a lot on the architecture which is being given to the structure. So in addition, there are limitations about the vertical transportation systems, you see, with the heights. जब आप height बढ़ा देते हैं, when it is excessive, the lifts and the escalators, you see. Limitations of the structural systems and materials, current construction processes, how we'll build too high. Somebody can come up and say that we have to build a 4 or 5 kilometer high tower. So limitation of the construction, equipments, techniques and processes. And of course, somebody as somebody questioned, the requirement of stability, which becomes of paramount importance, and of course, the strength of the underlying ground and the foundation materials on which the whole building has to rest. Here you see different architectural shapes, and we see plenty of them. You see a big variety is available in the Middle Eastern part, I would say, in the Qatar skyline, and in Dubai, you find a host of designs and you see shapes. So the front elevation views, you can see curvilinear form. Then you have a kind of, it is called setback. And here you see tapering. You see cross section reducing, going up, and adding opening. Some buildings are like that to allow for high wind to pass through. This kind of twisting shape, you see, this aesthetically looks good. Then a basic rectangular form, if you look in plan, the previous one were the elevation views, and here you see corner recession like this, corner cutting, corner slot, and this is called corner rounding. So, well, different shapes have been given, and there would be, I'm sure, shapes in addition to these two, just to give you an idea. So if you look at the skyline of different buildings of different architectural shapes, so they have these kinds of, mix-up situation. So architects do look at the environment also, in the ambience also, while planning a new skyscraper, while planning a new building, that what kind of shapes and materials and finishes have been used in the existing buildings which are in the vicinity, so that according to them, their design and their product that should stand out, you see, or that should look more prominent compared to the existing structures. Now, is there some question before going to this new topic? Nothing. I'll be discussing cases of types of foundations and the types of the underground foundation material, the ground type, in 3 big towers constructed in the world. The first I've selected to give you some information about Burj Khalifa, Dubai, which is a famous tower, the tallest building so far. Trump International Hotel and Tower, Chicago, and one of Malaysia, Plaza Rakyat. I've selected them intentionally with this thing in mind that there are different soil and rock types, different ground conditions, and accordingly, the heights are different of these towers. And the foundation types you see, which have been selected according to the technologies available in those areas. And you see the selection made by the engineers, how they go. So you will see that virtually different foundation systems, different foundation types
Now
have
we
been
are
used. Yeah,
where there
please.
is a question. We have
Yeah,
questions.
please. Yeah, sure.
Now you are entering the technical area of the topic. So let's finish what we have already said. There are some
Sure.
questions regarding this slide. Kamran Javed Siddiqui, he's saying it's about how much covered area you are getting, since in horizons you are limited. Did you understand the question?
Mhm. I think
Yeah.
I gave in one slide in the beginning that it is typical, you see, to cover the whole area, almost whole area, or up to even 80% or anything in between. This is a worldwide statistics. You see, this much area is covered, and I also told that the lettable area is about 80% of the total area which is constructed. Yes, please.
Okay. The second is a comment. I think it is Saad Saeed who is saying, is it a competition? Is competition a factor for tall buildings, as we can see in Saudi Arabia? I think it's everywhere in Saudi Arabia and UAE. What do you think?
Yeah, of course.
Yeah.
Competition.
Okay.
Yeah.
Okay.
You see,
I move to
this adds to the commercial value, and to the developers, it is likely to give more profits. You see, of course.
yeah.
So 3 tall buildings. Tahir, finished now? Questions up to now, or do you have more questions?
No, two questions quickly.
Please.
Ayla Wahid is saying, well, I guess the attention of tourists, one always need new things. You see, Burj Al Arab was constructed to stabilize economy. I think if you want to comment, okay. Otherwise, if you want to pass,
No,
I
it's
can
okay.
go.
There's already a comment. It's okay.
Yeah. Okay. Now,
Yeah.
the first technical question I got was at the start of the lecture. So now you are entering into the foundation discussion. So the question was asked by Kamran Javed Siddiq. Burj Khalifa Foundation is a pile raft foundation. Is it in practice in Pakistan?
Piled raft foundation. I think the person, Kamran, who has asked this question is also aware. He's just asking my comments on this. That in Pakistan, we should use this practice, you see, commonly for the reasons of economy. But I know that very few, I can count maybe on my fingers, projects are such in which the piled raft concept has been really used. Otherwise, you see, the cap is not taken as mat, it is just taken as the connecting medium to distribute the load to the piles, and 100% load in the design is given to piles. I think in more than 90 or 95% situation. Engineers should pay attention to this issue. A lot of research has been done on pile rafts, and it is very clear that the loading proportion, as much as I would say 20 to 40%, have seen the literature on this. 20 to 40% of the load is taken easily by the so-called cap, which acts as a mat. But there are certain limitations also of the ground. We cannot consider piled mat in every ground condition, because if the soil below the mat is not that hard or not that competent, you see, it cannot take substantial part of the load of the structure, and then the load is bound to be supported by the piles. I'll show this effect in some subsequent slides also. Okay. So
I have to make one announcement, please. So here, for the ladies and gentlemen, This is for everybody to understand. This is a technical lecture, purely technical lecture.
Yeah.
I will not allow any political question or any religious question. No matter how sensitive it is, I won't be allowing it. So please don't take the trouble of writing any text regarding religion or politics. Thank you.
Very good. I think that will be helping me too, because I'm not ready to answer any political or religious question too. And now you see how the capacity and stiffness of foundations directly influence the systems of their supported superstructures. ये देखिए आगे जरा, मैं आपको थोड़े इसके बताता जाता हूँ. Burj Khalifa already discussed 828 meters. Okay, tallest building. So here you see tallest building eclipsing the height of its nearest peer by almost 40%. Substantial. Completed in 2010, tops all three height categories. Then what it would be? Tall, super tall, or mega tall. Of course, more than 600 meters. So according to Council of Tall Buildings definition, it is you see in the last category, the mega. So you can see reinforced concrete multi-use tower, and but also contains retail space and Giorgio Armani Hotel too. Of course, those who have visited Dubai like me, we have seen this. You see, with the fountain show also, the famous fountain show of that place. So in the plan, the footprint of the foundation that somebody, I think Mr. Kamran commented, he already is aware of the piled raft system which is adopted here. So this is the footprint. You see there are three, you see stems, you see, which support the tower like this. Summary of the foundation system, pile supported mat. So what is the ground condition? Basically, in such Arab countries, in Middle East, we have sand, you see, present in a different condition of compactness, loose to medium dense in the upper zone. And then we have weak rock, calcareonite, weak rock, and calcareous sandstone. Basically, sandstones having different, degree of calcareous action, which gives different grades of cementation to the sand grains within the sandstone rock itself. So this kind of rock overlies gypsiferous sandstone, right, or some conglomeratic material too, or some calcareous siltstone. So you see there is some kind of variation. Groundwater is very high, at 2 meters below the surface, and also having high chloride content, very corrosive. But this is how it looked during construction. You can see the piles, you see top of the piles, and some mats, you see individual wing of tower raft. So here, see, the tower raft is supported by 194 board cast in place piles, 1.5 meter dia, about 5 feet, 43 meters in length. The capacity of 3,000 tons each means that the load test requirement will be at least twice. So it will jump to 6,000 tons. So 3,000 tons. I think those engineers who are connected with the activity of pile design and pile load testing, whether geotechnical or structural design, they would be thinking that this is a fairly high load, 3,000 tons. You see, the load depends on, the load to be borne by the pile depends on so many things. One factor is the ground condition. The second is the spacing between the piles, you see. If you reduce the number of piles, you see, for a structure, you see that the ground is strong enough. You may, you see, reduce the spacing, and you may adopt an optimum length so that you get your desired load carrying capacity. So diameter and length, you see, they have a relationship with the ground condition. The 6,000 ton pile load test which was carried out here, represented the largest magnitude pile of tests in this area, in this region. So this was the arrangement for this Burj Khalifa, for the pile of tests. What you see here, that we are test beams, you see, lying one over the other. There are three girders, you see, heavy girders lying one over the other at different angles, you see, so that at the central part, you see, they have at the bottom a jack which is resting on one jack or a series of jacks resting on the top of the pile in compression to be tested. So as the jack is lifted, you see, these girders, they are connecting through the reinforcement bar of the surrounding series of piles called anchor piles, which tend to be pulled out, you see, with the upward movement of the jack, which react against the girders. So tensile stresses or pull-out force would develop in the surrounding piles and resulting into transference of compression in the central pile. So this is how this was. There was no cartilage. If anybody amongst you was wondering that there would be huge cartilage, cartilages are not required for such heavy loadings. I think Tahir Sultan Sahab, if you're listening to me, you also carried out some tests with this kind of mechanism. I don't know what kind of, I think you told me once that what kind of load carrying capacity in compression was, which was tested by you in your system.
Well, we tested for the tension load and for the compression load, and I think the tension load was 660 kilonewtons and compression load was around 500
Okay.
kilonewton.
Okay, fine. But this is a very heavy arrangement, as you can see. So I've just given you you see, I'm not going into design details. If you are to design a pile of 1 meter dia or 2 meter dia or 3 meters dia in this kind of soil or this kind of rock, the design principles are the same. So I'm not discussing here the detailed or intricate design philosophy and design principles. The board piles are also called drill shafts. There's so much research in different parts of the world. So I'm just giving you see, how the tall buildings are supported, how these towers are supported in different parts of the world in different ground conditions, carrying superstructure of different heights. So here, Trump International Hotel in Chicago, Illinois. This was completed in 2009, and height is 354 meters. If you include the spire, the flat or the conical part, then 423 meters. The building is located in the north of Chicago River. Okay. So you can see here our foundations. So in the upper region, we have fill and soft cohesive soils, silty clays, followed by hard band material. I think from your courses of soil mechanics at BS level, you might have heard of the soil material hard band. So which is in fact, you see, hardened, a form of silts and clays, you see, by carbonaceous action. And in the areas where there are low rainfall, you see, where there is arid environment, so chemical bonds and linkages take place, which convert the silts and clays into tougher soil, rock-like material. That's not rock, that's called hard pan. So below the hard pan, there are dense sand layers and sand deposits, and ultimately the underlying material is the limestone, dolomite limestone rock. Limestone itself is calcium carbonate, and calcium magnesium carbonate is called dolomite. Bedrock formation on the site were located 34 meters below the existing ground level. So this dolomite rock was 34 meters below. For these geotechnical conditions, buildings of moderate loads are typically founded on belt caissons in the hard pan, because that is also good material. So for moderate heights, hard pan. but for supporting the heavy loads, the rock socketed caissons. Caissons are you can think large diameter drill shafts. So they have been adopted. So in the highly loaded areas, the core of the buildings is supported by a 3-meter thick reinforced concrete mat that transfers the enormous core load into 24 3-meter diameter rock caissons. So caissons are socketed in rock. They are 3-meter dia or 10 feet dia drill shafts, which are supporting the structure underneath the mat. The perimeter and interior columns are supported by 33 individual caissons of 2.4 meters or 8 feet dia. Capacity of the core is largely controlled by the number of maximum diameter 3 meters caisson that can be located within the footprint area.
Well, sorry, Sohail. When you have so many participants, it's difficult to control. Anybody whose mic is not unmuted, please unmute your mic. Hasnan Safdar Sahab, please unmute your mic. Yeah, Sohail, you can continue, please.
So
अस्सलाम वालेकुम सर आप भी म्यूट कर सकते हैं, जो होस्ट है वो भी म्यूट करवा सकता है, आप म्यूट कर सकते हैं खुद इनको.
I would request all the participants, please do not jump on the mic. I am taking care of the situation. Kindly have some patience. There is some interruption at the end of the speaker. Give him a little bit of time and he'll come back on the mic.
I'm sorry, I've come back. There was a kind of my small grandbaby, you see, she came, she's 2.5 years. She came all of a sudden and I had to manage, you see. Now she's gone back. So here you see the under construction process, you see, as I think you noticed just a minute. Yeah. So I was talking of the mat and the caisson business. So here you see the caisson being poured, and you also see the excavation support system, the studding done to support the excavation works here. So in 2005, a successful O-cell test were performed on a rock caisson. You know what is an O-cell? I think some of you might be doing this O-cell and test by using O-cell. It is a bidirectional compression test, you see, in which the jack is embedded at any point within the shaft. Sometimes it is embedded at the base. If it is embedded at the at any place within shaft, you see, the lower part below the jack will receive compression going down, and the upper part of the pile will start moving up, you see, so giving you a kind of blend of skin friction and you see things like that. So City of Chicago granted a code variance, you see, 270 ton per square foot, highest allowable pressure, you see. So very interesting. So this increased building capacity coupled with the utilization of 69 MPa compressive strength, cylinder strength concrete in the caisson allowed for the design of this tower to reach a height of 92 stories. So I think in today's lecture, I am amply describing the relationship between the concrete strength of the foundation material being used, the load which is coming from the top and the bearing pressure you see, and the type of the foundation material, how they are interrelated. So because the accessible dense rock formation which support Trump Tower, the foundations are largely controlled by strength and constructability constraints. So here the foundation settlement surveys showed during construction total settlement of the order of only 6 millimeter as compared to the value which was otherwise you see fixed on the basis of calculation, there is always a disparity. So this is the view you can see. Beautiful. Third. Any question till now? No more question?
No, I have a question, but it is a very basic question. So I
Very
hope
basic. No problem.
you have already answered it, but let me check if Hassan.
No problem. Because there are
Hassan,
students here, the lecture has to be beneficial for the students.
yeah,
Yes, please.
Hassan, no, you have already discussed it. He might have
Okay.
understood. But if you want to say something, please do. What is a pile raft foundation? Can you explain a bit?
A foundation system, you see, Hassan, I would like to ask from this fellow, is he a student or a practicing engineer, first of all, so that I reply to the level, to his own level, you see. That's up. Can you get a reply from him? Is he a student of some year, second, third year? Final year?
He's a student.
Okay, very good. So I tell you, you see, you might have seen in your experience, wherever you are living in Pakistan, whether in Peshawar or Lahore or Karachi or Islamabad or any other city, that when piles are constructed, a cap is provided on the top. We call it pile cap. And in our design practices so far, cap is considered to be provided to distribute the area to the pile underneath. But this has been a thinking in the world that this is reasonably thick enough, rigid enough structural member also. So why not to give a kind of a part of the total load of the structure to the cap also. So in the case when the cap takes a part of the load in design and it is designed as such, it is acting as a mat. So underneath, the piles which are connected to it are loaded to the full capacity. This kind of system in which a part of the load is carried, or the total load is carried by the cap, which we call mat, and the remaining part by the piles is the piled raft foundation or piled mat foundation. Okay. Now let me discuss the third main structure which I want to bring forth here. Kuala Lumpur, partially built mixed use development. Kuala Lumpur's busy Thorpe project was anchored by a 7th century of
मैंने भी आपको व्हाट्सएप किया उन्हीं से कॉपी करके वीडियो बना
We are having some technical issues, Sohail. Neither your
can you see me and can you hear me please? आप लोगों को मेरी आवाज आ रही नहीं?
You are audible now, and we can see the share screen also.
Very good. And the screen is mobile, is moving, dynamic है ये, ठीक है, okay.
We are on slide number 54.
Very good. So this project was intended to be 77 stories, you see. Let me have it was on a swampland, located a large rectangular site which had previously been swampland, marshland. The project's geotechnical conditions and below-grade transportation infrastructure provided engineers with formidable foundation challenges. You see, आप एक swamp area में construct करने जा रहे हो, आपकी जो basements हैं, आपको कई challenges हैं. The lateral earth pressures and the seepages you see below the grade. So look here, ये इसका floor plan इसका इस तरह का शक्ल इसकी है. So इसमें 3.5 thick reinforced mat foundation है, and it is piles. So again, pile mat. All piles are only 900 piles because of the load reversal effect load in the design. So they're 32 meters. So the underlying rock formation is called Canny Hill Formation. Piles are spaced 2.7 meters. So this rock formation is a sedimentary rock comprising shales and mudstones and siltstones and sandstone like we have in Murray area. So significant part of Kuala Lumpur city is having the same kind of formation which we call Murray Formation here in Pakistan. So here you see pile has a working load of around 700 metric tons. Deeper piles were specified below the central core area also based on the higher vertical loads in the central part. अच्छा जी, आगे चलते हैं. So you see here very briefly it's pile mat system. A question might come to your mind that why the diameter of the pile is too small here. If we want to derive good skin frictional resistance, you see, from the deep and of relatively weaker soil, then we have to increase the skin area of the pile, and that is possible by reducing the diameter and number and increasing the number of such shorter diameter piles. So ये भी एक इसका तरीका है. Anyway, this is a model, you see, just to show you.
So here we have few questions. I
Yeah,
think
sure.
it will be better to answer at this stage, huh?
Please, please.
Yeah, this is from, this question is from Nabil Ahmed. He is asking, sir, what is the criteria for determining number of spacing and depth of boreholes to be drilled during the geotechnical investigation for tall building? Does this criteria change with decreasing height of the structure?
Well, first thing that the number and the diameter of piles are based on the interplay of the work of geotechnical engineer and structural engineer. You see, the loads are controlled, you see, and they come from the structural engineer. Geotechnical engineer has more knowledge and information about the ground properties. So what is the optimum? You see, different combinations are tried, and the one which is optimum, you can say, cost-wise and efficient in construction from constructability point of view also. So that system is, you see, selected. There is not any generic answer to your question. It has to be done, and some trials have to be made, and then ultimate selection is made. And sometimes such selection is made on the basis of some pre-limited studies, even at the tender stage, even before the start of the work, based on some approximate evaluations. The diameters and length of the piles and some load tests are also run. They are already decided, you see, and they are only adjusted on the basis of the pile load tests after the execution of the load tests. So it is like this, okay. Otherwise, the answer to your question is a whole lot of textbooks, okay. So here I'm comparing. JJ, please.
Two more questions. One is from Nadeem Mahmood. He is a senior engineer working in Lahore. He is asking, can we have different lengths of pile on a single cap?
Well, this is what many engineers do, and you see, it depends that which type of loads they are carrying, you see. Well, it's good, but it creates and poses construction difficulty. And solutions to this, to make the load transfer more uniform, some inserts, you see, some stiffeners inserts, and you see composite stiffener inserts have been, you see, developed, and they are also used. But this is possible, and people have been doing this. This apparently at design stage looks like that, that it's saving some, you see, some cost also. But if we make too much of variation in the pile lengths, you see, for the same building, you see, it adds to the construction difficulty also. And it's not only the structural issue, you see, it also depends on the ground condition. I remember the case of the construction of piles for Pakistan Engineering Council buildings back in 90s. I was there at site. And there was, you see, the ground formation there consisted of degraded resident shale deposits, which had almost converted into clay because of differential weathering. The effect of weathering was deep enough at some places, and it was not that deep at other places. So naturally, the pile design was such that past the weak degraded upper part of the shale, it had to be socketed into more competent, was governed and controlled during construction. Hello, can you listen? Am I audible? Hello, can you listen?
Gigi, you are very much audible. Please go ahead.
Okay, okay. So sometimes ground conditions dictate variable lengths of pile, and we have to live with those, no matter how difficult the constructability is. You see, it is not the design office all the time, which gives a very good control over the pile lengths, and not even the load tests. You see, sometimes the geology of the area, that becomes the controlling and the overriding factor, and we have to consider that in view of the safety of the structure. So now they are extending the Pakistan Engineering Council building right now, and I'm also having information, technical information about that, what is being done there. The same, almost same policy is being adopted again. So it happens like this, that the contractual piles or the pile decided on the basis of geotechnical studies and structural design and pile load tests, they are not strictly adhered to according to variable at differential ground conditions sometimes. So here you see, in case of Burj Khalifa, the pile supported MAD provided the required strength and settlement control. So this enabled the construction of the world's tallest building. For Trump Tower, the strength and constructability of the caissons were the controlling elements. Bedrock strata provided outstanding settlement results, as you saw. And for Plaza Rakyat office tower, the normally high variable strata of the Kenny Hill formation, which was, I told you, like muddies, shale, siltstone, and sandstone, was determined to be consistent enough over this project area to enable the more economical drilled friction type small dia piles. So this is a very beautiful business, you see. The foundation area, a blend of geotechnical and structural engineers' expertise, where nothing is fixed, nothing can be given as a final solution for every kind of situation. There's no generic solution. That's why geotechnical investigations with, you see, reasonable level of accuracy and magnitude becomes more important in such tall buildings, so that we get proper information and we can have a very reasonable foundation system for them, suiting the actual loading, actual environmental condition in terms of earthquakes and winds, and the actual ground conditions. जी, any question? फिर हम इससे 3 बिल्डिंग से हम निकल रहे हैं, अब आगे जा रहे हैं. We are going into some interesting considerations. No question till now. Okay. So
we have question.
Yeah, question. Okay.
I think you have already answered it partially, but please make it a little bit brief. This is again from Nabil Ahmed. Please comment on what is the limit in horizontal direction up to which we may use the results of a geotechnical investigation. For example, if we have performed detailed investigation for a given building and later we have another building planned within 10 meters of previous structure, can we use the results previous investigation of this new building? Another one, sir, I want to clarify, earlier asked about geotechnical investigation criteria, boreholes based on your extensive experience. Quickly, please, quickly. We have a short of time.
Now, please don't force me to go quickly. Let me laugh over some questions also. You see, I'm sharing my smiles also with my with the students also, which are sitting here. First of all, you see, no matter how profound geotechnical investigation you carry out for structure, say for a building site in Lahore. आज हम लाहौर में बैठे हैं, आपका फर्ज किया 100 by 100 meters का एरिया है, आपने वहाँ बिल्डिंग कंस्ट्रक्ट करनी है, आप 100 बोरहोल कर लेते हैं. Even then, you are getting information of the ground only at 100 points. You are not getting 100% information even in that case. Yes, one sensible engineer could come out and say that we are having a reasonable data. Now, when we have a reasonable data, it's the extent of variation in both direction which the engineers, sensible engineers, will look at and find out that what is the order of variation. आपने कहा कि 10 फुट परे 20 फुट परे भी वही डेटा की एप्लीकेबिलिटी है कि नहीं. तो with all the reservations, बहुत सारा डेटा हो और वेरिएशन का ट्रेंड बता रहा हो तो आप कुछ उससे अखज़ कर सकते हैं. बट इवन देन you don't have 100% reliability. अगर आप स्ट्रिक्ट सेंस में बात करें, जैसे मैंने कहा, देखिए जी, आप एक साइट जो है 20 by 20 मीटर 5 बोरहोल करके इन्वेस्टिगेट कर लेते हैं. So in reality, you have not x-rayed the whole 100% area. You have just found the geotechnical characteristics at only 5 points. So ये एक आपका आगे आर्गुमेंटेटिव लॉजिक बन जाता है कि हमने इस पे कितना रिस्क एक्सेप्ट करना है या नहीं करना. ठीक है ना जी. तो कुछ अगर उस एरिया में लगता है जहां आपने पहले इन्वेस्टिगेशन किया कि वेरिएशंस काफी ज्यादा हैं एंड परहैप्स दिस एरिया इज akin to geotechnical surprises, तो आप फिर करीब वाली साइट पे भी, और अगर वो इंपॉर्टेंस की हामिल है, तो कुछ स्टडीज जरूर कर लें. व्हाई टू सेव सम पेनीज टू सी एंड टू पुट द सेफ्टी ऑफ द स्ट्रक्चर इन jeopardy. एक तो ये हिस्सा हो गया. दूसरा मैं ज़हन से निकल गया. आई थिंक यू विल हैव टू रिपीट दैट साहब. एक तो ये बात थी.
I want to
Second
clarify.
question.
Just a minute. Go back. I want to clarify. I earlier asked about geotechnical investigation criteria for boreholes based on your extent. No, yahi tha. I think he wanted to clarify. Please go ahead. Continue.
Oh, ये जो the criteria you're talking about, this is given in normal code. You see, it is based on the basis of the stresses, you see, which we accept, to which we want to investigate. We want to investigate under the estimated stresses at the investigation stage, like 10%, you see. And if we have some already available information, as we say, of the vicinity, यहाँ ख्याल है कि यहाँ डीपर डेप्थ तक फॉर्मेशंस काफी वीक चलती हैं, then we may have to deepen. So इसके various rules of thumbs हैं जो कि different codes और किताबों में already दिए हुए हैं. Older rules एक ये भी होता था for buildings that the deepest point of penetration of investigation for a building should be at least equal to the height of the building. ठीक है जी. फिर ये भी हो गया when we are planning geotechnical investigation and the designs are not final yet, then we estimate that what kind of foundation system, mat or pile or spread foundation, is most likely expected. So उस most likely expected की केस में जो most likely stress zone बनेगा, उसकी depth of penetration कहाँ तक है, उसकी basis पे investigation का फैसला हमने कई दफा किया है. And textbook और codes और किताबें भी यही बताती हैं. I think that's my idea is that interactive session, inviting question during the lecture, I think this gives a more understanding to the participants regarding the depth of the study than to discuss so much and going breadth-wise. मैं चाह रहा होता हूँ कि लोग उसमें interactively शामिल होएं और अपने जो उनके ज़हन में खदशात हैं, whatever confusions they should discuss and remove. So it's good. I'm not worried, even if I'm not able to cover the whole topic, but I'll be delivering something, you see, which is important with discussions. So now let us.
So here two things you must note. At least we have one participant on Zoom who cannot understand Urdu, and there and we have 8 or 9 participants on Facebook. Maybe some of them cannot understand Urdu. So kindly avoid speaking Urdu and just keep a note that maximum you can go up to is 4 o'clock.
Okay. First of all, my apologies. One participant, she's my colleague in the profession, Miss Tatiana Tronda. from Belarus. I'm extremely sorry. I just forget this protocol, and I will be just sticking to English language. I will not speak the remaining part of the lecture in Urdu. So let us discuss some major challenges you see in regard to the geotechnical engineering of tall buildings. We have to get to grips with the ground. We have to get information, more information, familiarity with the ground, with reasonable geotechnical investigations. Presence of random cavities in the ground is very serious, because in the Middle Eastern development in particular, sometimes we have projects in Middle East and people who are designing in Middle East where there are limestones in abundance, there are cavernous limestones in particular. Though in some other ground formations also there could be surprises. I would like to ask Ms. Tatiana Tronda if she can be allowed to speak, that what kind of ground formation is there generally in her country, in Belarus? If she is listening to me and if she can comment on this, it will be good for the benefit of all and myself too.
Good afternoon, everybody. Can you hear me?
Yeah, you're heard.
Yes. So, what kind of formations we have in Belarus? In most cases, we have sedimentary soils. I mean, in most cases, we have sands, clays, sandy clays, and something like this. We don't have rocks, and so
you have river-laid deposits. Okay, I got it. You have sedimentary deposits laid by river, by water. Okay, fine,
and
I don't think you have okay. And you don't have surprises like cavities, I think, in those formations. Generally not.
Sorry?
You do not have cavities, the holes in the ground in Belarus, or do you have?
Maybe, but I don't know.
Okay.
Generally, no.
No problem. In sedimentary deposits, you see, like we have in Pakistan too, like in this city also we have sedimentary deposits. The kind of problems in place of cavities which are more pronounced and more frequent are the weak zones or the lenses of weak soil, you see, embedded within the relatively stronger layers of soils. So we do have lenses, I mean, soils inclusions of limited thickness, but of marked weakness. If we think in terms of SPT, sometimes we have zero SPT blow, and there is a phenomenon of self-penetration of the SPT rods. And you can also conceive in terms of cone penetration tests that the penetration could be just very quick without any substantial application of force. Right, Tatiana? Thank you. Then the next challenge is the digging for deeper basements, digging into difficult soils. When I say difficult soil, that not only hard stuff, that could be problematic soils of any type. You see, I'm talking with reference to the collapsible soils whose structure will underground a breakdown because their structure is metastable, it is quasi-stable. Upon wetting, it may break down. Or there could be incidences of swelling soils in which the inclusion of water will give rise to increase in volume, which can, depending on the type of minerals, can exert tremendous stresses, you see. So their knowledge is very important. I encountered a highly swelling soil near Khairpur in Pakistan. That was the area with the highest swelling soil, although I've encountered swelling soils at many other places in Pakistan in my experience, like at Nandipur, where the earth is taken for making cricket pitches, because that is swelling soil is a hard soil also, like in Dera Bukti. So this is Khairpur. The estimated swelling pressure on the basis of laboratory tests there was 10 tons per square foot. And a university campus, single and double story buildings were planned there. Can you imagine they could withstand so high swelling pressure? 10 tons per square foot. So since they were not investigated properly, and while the construction was underway, only walls had been constructed, no roof was constructed yet, that there was a torrential rainfall. One night there was a heavy rainfall, and there was significant, horrible damage to all under construction works. So the owners had to simply abandon the site. I was there at site. I just saw it, and we concluded that nothing can be done to repair or to use it further. So such are, you see, the situation. And then next is relieving the pressure on retaining structures. Yeah. What should be done to have less lateral pressures in tall buildings with deeper basements? Type of soil could be varied, control of water, allowing the water to flow at the back, you see, to drain it properly, and proper drainage, giving proper drainage system, you see, then the buildings have to stay stable under all eventualities of forces. It's not only the question of static load and live load and direct load, but also the transient loads, the earthquake load, the wind force. Then one has to design for the foreseeable future. And you see, for the 60, 70, 80, 100 years, and similarly gaining ground, you see, by virtue of this. So I've already talked about getting grips to the ground, that this is that sufficient studies and analysis have to be carried out to have first-hand information about the intricacies of the variation in the geotechnical character of the ground to design the structure with minimum risks. Then the next I would like to emphasize is the correct assessment of ground. That the construction cost of basement and foundations of tall buildings are only a small proportion of the total cost. As I told you in some previous slide, you see, a statistical average like 7%. Any errors made in the ground or subsoil assessment using wrong technique, uncalibrated equipment, you see, cheating practice or whatever, and planning can result in significant building damage. Once the damage is there, the delays and additional costs could be very high. So there's a great deal of value to be gained and risks to be avoided by ensuring that ground conditions or the geotechnical conditions are evaluated for tall buildings in a very, very professional manner according to the codes and standards. So let's pay attention to some further important considerations. There is substantial or very high magnitude vertical load, differential settlement because of low and high rise structures could be there. How to resolve those issues? High lateral loads and moments because of the wind and earthquake loading in particular would be there. Cyclic lateral loads and moments, additional loads due to seismicity, inertial movements, and kinematic forces, and phenomenon of resonance based on time period doctrine could be there. Here I am, you see, it is a very crammed up slide, but I just want to give you a feeling that key design issues, you see, for tall buildings are quite similar to the design issues you see for other buildings also. But you see, we cannot ignore, you see, many important things. Like you can see the influence of cyclic nature of winds and earthquakes, differential settlements within the tower footprint and the high and low rise areas, possible effects of the external imposed ground movements on the foundation system, like consolidation settlement or adjacent excavations, or if there's some kind of tunnel. So earthquake effects and dynamic responses of wind loads. So you see, there are a variety of design issues. If we had, this is again a crammed up slide, I will not read it, but I will just let you know that the design steps with all the minor details are very, very similar to the design steps in any civil engineering design work from geotechnical point of view, that you plan investigation, you execute, and a proper supervisory cover at the site. You carry out laboratory tests. You, analyze those, evolve soil parameters, decide about the foundation types, their depth, and carry out tests on piles if pile foundations are there. And then, monitoring. It is very important for tall buildings to monitor the movement, the behavior of the structural systems and foundations. Are they in agreement with what was predicted by calculations at the prediction level stage? So these were the design issues. You see, I told you they are quite similar to other works also. Now let's talk about some social aspects. You see, I've not included any political aspects, but social aspects have to be considered. You see, the reason is when we talk of the sustainability, which is the talk of the town today, for every kind of design and every kind of project, then we have to pay attention to three issues when we talk of the sustainability of the project. That it should be socially acceptable, that it should be environmentally acceptable, and that it should be financially acceptable. I mean, it should be competitive in cost. The environmental factors have been taken care of, and socially, you see, the inhabitants who have to occupy this and the people who are in the surroundings, they don't make any uproar. ठीक है ना जी, वो you take, sorry, I again said ठीक, let me go in English. So social aspect, accommodate the rapidly increasing population. This is one social aspect, that tall buildings accommodate the rapidly increasing population. Is the pros, the positive points. Is the positive social. They reflect the development of major cities. They promote urban regeneration of depressed areas, the areas which in urban locality, like in Lahore, there are slums, like areas which are less developed, and the areas which lack urban facilities. So they need a regeneration, providing of the facilities as in the other parts of the city. So that is urban regeneration. Increase productivity by access to denser markets. Economic response to high asset values in big cities. Promote sustainability via compact living. So energy saving, space saving, so ultimately cost saving. Resulted to energy, fuel and time savings, potential for exploiting geothermal energy. That tall buildings provide the opportunity to use the thermal energy of the ground. That is, there's a difference of temperature between the ground and the atmosphere in summers and winters. In winter, this is cool outside and it is warmer within the ground. So why not to utilize that heat of the ground during winter, and during summer it is the other way. It is hot outside in the ambience and it is cool here within the ground. So why not to make benefit of that too? I think you got my point of view. Can promote the city as a leading commercial center, resulted to advances in engineering and technology by building tall structures. Because they, as I've already explained to you, they would require research on different types of materials, stronger materials, construction techniques, construction machinery. So that leads to the development of engineering and technology when we have tall buildings. And there are some negative effects also, the contraries. They involve a cost premium due to their complexity. The cost may increase, you see, and if architectural renderings are very frequent, you see, so you can see cost can go, can have adverse environmental impacts on microclimate. On a small climate, in the same area, the microclimate, the climate which is surrounding those buildings, that is called the microclimate, not the regional climate, can have adverse environmental impact on the microclimate, like wind funneling. You see the wind funneling effect, in which the wind is there, it can blow through a narrow space at a higher speed and casting shadows on the other buildings. So reducing the daytime light and the heat effect, you see, which could be desirable in some cases. So this is one negative impact, can lead to civic problems like overcrowding and traffic congestions. Socio-psychological impacts. People sometimes don't like small spaces, and you see they have kind of claustrophobic effects. And you see living in small units, it requires a kind of mental training. So you see this kind of tendency is there, but this is a trend in the world, you see, to resolve the inhabitation issue, the housing issues. Unpleasant shape or inappropriate locations. Concerned about public safety. Somebody, I think, put a question in the beginning that they could be less safe compared to the less tall buildings. So there could be some concern in some quarter in someone's mind. But as I said, some measures accordingly, whether engineering measures or some safety measures otherwise, can be adopted and can be considered, but that will add to the cost also. Potential to reduce positive human interaction. People remain, you see, blocked and in the close-up their quarters, and you see human interaction is already reduced because of the artificial intelligence, the IT. So they will further have the tendency of reducing the interaction. Now, foundation requirements, once again, with emphasis on building and foundation movements are interactive, as I've told you. Of course, they are. Foundation design has to be performed based on soil structure interaction, SSI issue. It's not in isolation. We can have separate geotechnical studies and separate structural studies, but they will be just, and you see, you can say a broad estimate. It is basically SSI, and softwares are available nowadays to take care of so many of such boundary issues of structures in geotechnically tall buildings. Essential to have accurate knowledge of ground. Local experience must be included, of course, as in any other situation too. Site investigation should be supplemented with instrumented vertical and lateral loading testing of piles, and such loading tests must be carried out before finalizing the design. They were the particular foundation issues. Now, a little discussion on the architectural forms. Architecture is very important in tall buildings. It's not only engineering all the time, the structural engineering and the remainder geotechnical engineering. I think architectural effects, they sometimes take lead. Base plan is mostly square or rectangular. Future trend is for twisting buildings. This is what we are seeing. Trends of super slim, aerodynamic and curvilinear shapes, that is coming up. Trend of having aesthetically designed buildings. The more money you spend then. Architects may put heavy challenges on structural and geotechnical engineers by their innovative ideas. You see, architects have their own domain. They think of large spaces and beautification. The architects may think of putting one big building on just 2 piers. So, theoretically, to put a big building on 2 columns, theoretically it might be possible, but it's not practical. We have engineering solutions from structural and geotechnical point of view, but nobody would admire such things. So there has to be a limit to be put to the vision of the architect. So in a nutshell, the business of tall buildings, the design of tall buildings and the construction of tall buildings is the interaction of the 3 professionals, the architect, the structural engineer, and the geotechnical engineers. So as I've shown you already, the foundation systems in 3 example cases, here I'm repeating that worldwide, these are the systems which are adopted in general. Shallow raft or mat foundation, or mat and raft foundation at deeper depth, providing basements, thereby having the compensating effect to reduce the settlements in weaker ground. That's called compensated raft foundation. Pile foundations, which are circular in general if they're drill shafts, or large diameter foundations called barrettes. Barrett foundation is large diameter, general rectangular, you see, depending on the type of the excavating equipment. They are large type rectangular foundations, and normally clamshells are used in their excavations. If some of you are familiar with the clamshells, which are used for the excavation of the diaphragm walls, also the thin walls. Then there are pile draft, which we have talked a lot about in this lecture. The pile draft foundation is the one, again to repeat, which derives a part of its resistance of load carrying capacity from the mat, from the cap, acting as a raft, transferring some load onto the ground directly and a part from the pile. And such pile drafts, if they are provided with basements, then they will be compensated pile draft foundations. Similarly, large diameter drilled shafts, they will be called cast-on, or like 3 meters diameter, 4 meters diameter, even more sometimes. Factors for selection of foundation type, how we have to select, you see, I think it's almost similar to the selection of the foundation system for other engineering situations. The basic principles are the same, but one has to see the light of the loading and the ground conditions for a taller structure. And please keep this thing in mind, that as engineers, the indigenous materials and the indigenous technology, sometimes that is cheaper for almost same efficiency or slightly reduced efficiency, and that is preferred always. I think we have already talked about a variety of these issues.
So here,
I will show you.
so here,
Pardon? Yeah.
You have to wrap it up in 5 minutes. We are very now, it's 4 o'clock. We are
Okay.
very tight. With the
Yeah.
time.
Okay. And also because we have already have had so many interactive questions and answers, so no need of separate discussions. Okay, I will just wrap up after this slide. I will just show you two innovative foundation types, which can be used also for tall buildings too. One is the shell foundation. So it consists of a conical shell with edge and ridges and beams running under the edges to support the columns. Loads from weak near surface soil can be transferred to the strong formation. So sometimes it is economical, and other is the micropiles, which are finding their place now under many structures. And if there is a weak, medium, and overlying strong formation, then a series of micropiles called a reticulated micropile system, a network of micropile system is provided in those cases. So they have a good capability of covering up the voids, the cavities, and the empty spaces too, if they are existing under the foundation system. So look here, the shell foundation. As I told you, it's conical one, and with beams under the edges. You see, if you look at the plan, beam under the edges, so it acts like a shell. You see, hyperbolic paraboloidal shell. And this is a micropile network, the reticulated micropiles. Very useful. You see, require little machinery, less headroom, etc. So I think I should finish here because we are running short of time. I would like to thank all the participants for their intriguing questions, for their good interest in my lecture. And thumbs up if you feel that you can allow a couple of questions. I am available. Thank you very much.
I already have 3 pending questions which
Okay,
came in
please.
chat box. I will read one by one and you please answer it.
Okay.
Khan Shahzada asked a question. I don't know how related is to present topic, but if you can answer it briefly, please do it. Could you please explain the construction process of secant piles?
Secant piles are the one. I think this fellow knows already. He just wants that I should reply to his question, and others should also listen. And it's good way of sharing. Just
Please, Briefly, please.
So secant piles are the one you see in which we first make reinforced or unreinforced pile, you see, as the first line of pile with spaces in between, and then the spaces in between are again piled, you see, provided piles, so that those piles which are provided in the second phase cut into the existing piles. So when there are seepages and things like that, you see, they put a very effective control, you see. Not only they control the horizontal forces, but also they control the seepages. Next.
Next is from Shafiqur Rahman. He was on Facebook. He's asking, there is a well-known formula for SSI in J.E. Bowles' book for compression-only subgrade. If someone intending to model a retaining wall with frictional springs in lateral direction, then what is the suitable method to calculate such springs lengths? Please suggest some good references for our guidance.
I would say that it will be structural analysis. You see, if he's a geotechnical engineer, he'll be giving his feedback to the structural engineer. It requires some proper suitable structural analysis program to resolve this kind of issue. And I think softwares like Plaxis, they also have capability to provide the answer to the solution to some extent. The next.
This is regarding software. 2-3 questions have been asked. So what I'll just Kamran is asking, then Rishad Khan on Facebook, he's also asking the same question. Which software gives the near to reality picture of subsurface data? And Irshad Khan is asking, currently in Pakistan, we use ACI 318 UBC for buildings with software CSI, ETAP, SAFE, and SAP 2K structures. Sir, what were in practice codes used between 1990 to 2000 for building structure in Pakistan and foundation designs, which were common softwares in practice in that era? I hope you have understood the questions. Please answer.
Yeah, the second question first. The second question is heavy in the structural engineering domain. So I will not answer that question here. Okay. This lecture is about geotechnical engineering, which is my field of specialty. I think we cannot answer that question here. Number one. Then the first question was, can you repeat the first question again, please?
Which software gives the near to reality picture of subsurface data?
Okay. You see, now good softwares, you see, have come up in geotechnical engineering, and I'm I'm an engineer who very much appreciates the Plaxis and its, its good usages. One thing I tell you, that such softwares, you see, the engineers have to be, hands in glove with the modern software tools and modern artificial intelligence systems, numerical modeling, etc. But we have also to put an eye on the fact that what are the basic parameters, how they are derived, the field parameters, the laboratory parameters. And when there is a lot of data, hundreds and thousands of data, there are files of loaded data. What kind of data we have to precisely evolve and arrive at after analyzing and converging that big data, which can be plugged into either mathematical equations or in the softwares. Otherwise, that is more important even than the use of such softwares. I've seen engineers using softwares blindly, but getting very erroneous and misleading results in a number of situations. So those techniques, have to be learned with patience and with diligence, and how to evolve the parameters which have to be fed in the software. Whether you are using Plaxis or iTesca or some other systems, you have to be very particular. Number one, that how do you reduce the big bulk of data into the usable soil parameters, number one, soil and rock parameters, and number two, whether the data was credible enough or not, which was generated by the process of field and laboratory investigation. This is very, very, very important. The accuracy obtained otherwise by running software will remain a fictitious accuracy, I tell you. Next, sir.
I hardly have any time for further questions, but since two questions look to me very pertinent, so please be brief. Sohail, I will request you. I'm very hard pressed with the time. Now, this is Hasnain Safdar. He is asking what technique can be adopted while placing foundation of building on expensive or swelling soil.
Well, you see, I will give you a very, very broad kind of answer because otherwise the answers are, very, very lengthy. As I told earlier, also in reply to some other, a whole lot of textbook on expensive soil. You see, you can provide a foundation if we provide a kind of mat kind thing where with hollow spaces, you see at its bottom, a waffle type mat foundation, you see hollow gaps at the bottom, number one. Number two, we can provide foundation in such a way that the loading intensity is increased. I would prefer in case of swelling soils, if it is a light structure, square or rectangular foundation than a strip foundation for single, double, triple story, because that rectangular or square type foundation will tend to concentrate load, put higher pressure onto the ground to counter the swelling pressure. But at the same time, a good connection of those foundations can be made with the beams, with the interconnecting beams to make the system comparatively more rigid. That is one thing. Secondly, sometimes we can take the foundation loads in swelling soil using double casing technique via piles into the load strata up to which either water cannot reach to cause swelling or which are non-swelling soil located at some deeper depths. Load can be taken directly there, bypassing the swelling soil, putting a double casing, you see, kind of effect by eliminating or separating the movement on those swelling soils from the piles. But I have not told you the key number one, the solution number one, which is very, very important. That is avoid movement of water in the swelling soils. Have a very effective drainage control. The seepage of water from the outside sources as well as from the sources from the plumbing and sewerage works from within the building. So if that is done, the swelling of the swelling soil will not take place in itself. Jeeta.
This is the last question from Rishad Khan. Please recommend an economical equipment which gives subsoil strata information in deep soil and other properties. I am talking this as replacement of SPT, where we need number of blows and sampling.
Gentlemen, don't think of replacing SPT straight away. SPT is the single in situ test in geotechnical engineering, which is having the largest database worldwide. Please listen to this thing. Even in USA, Canada, in Europe, CPT has been used more frequently. So there's a large database of CPT. Many geotechnical engineering practices and theories still have the state of the art using SPT, like liquefaction analysis, which was originally developed using SPT, is still run on the basis of SPT, and the results are fairly acceptable. So I'm not against using the other modern method like use of dilatometer, you see, and use of other techniques and pressure meter, you see. They have their own benefits and their own limitations too. So actually, SPT should not be replaced, in my opinion, particularly in our country. Yes, some other techniques, as I have mentioned, may also be used in mega projects, but SPT should stay there. It is cheap, labor can perform, easy to perform. Next. Your mic is muted, Taisab. Your mic is muted. Nobody can hear you.
I'm sorry. I think we have to close the session here. We are almost over with the time. So then we land up into problems with our recording. So thank you very much, Suhail. That was a wonderful lecture, very knowledgeable, and the participation from the audience clearly indicates how interesting your lecture was and how much knowledge they must have gained. Thank you very much.
Thank you very much. One small comment. We can fix in future for the same audience if they like, and it depends on you to a part B of that, because a very a bulk of useful information of this lecture I couldn't deliver because of paucity of time.
Okay. And a few people have asked the question that how can we get this lecture? Ladies and gentlemen, this is for the information of everybody that all our lectures, lecture number 1 up to today's lecture 48, they are saved on our website. www.psce.org.pk or .com.pk. Both are working, I think. So you can go to our website and you go into the lectures. There, all the lectures are saved, and you can probably download them or you can view them there and then online. So this is the only way you can get our lectures. So now we have to conclude it, as we are already surpassed our allocated time. Kindly note the next lecture is on 17 December 2022. The topic is effects of magnitude 7.5 Manjil earthquake of 21st June 1990 on the 106-meter high Sefard Rood Buttress Dam in Iran. And our speaker is Dr. Martin Wieland. I think he would be delivering lecture outside Pakistan. I really don't know which country, maybe England or Thailand. I'm not sure at the moment, but the time, the date would be 17 December. Time will be announced as per convenience of the country from where he will deliver the lecture. Certificates can be collected from 16th November 2022, which is Wednesday. And please note that our address has changed this time again. And I promise this time is the last time that we have changed our address, which is 14A1 Block P, Model Town Extension, Lahore. And telephone is the same, 03474625111. And Ahmad Akram is the person you have to contact for the certificates. And let me put it on the share screen, the address, so that everybody know. Just hang on, just a second, give me a second. Yeah, this is the collection of certificates. You can note down the address, collection date, collection time, and the person you have to contact. So this is it. I hope you have noted down. So now we have concluded today's program. Thank you very much again, Suhail Kibriya. Thank you, Mia Saab, for your presence. Thank you, Tatiana, for your presence too. And thank you, Nadeem Mahmood Saab. Today I saw you after a long time. Thank you very much. So God bless, Allah bless you all. And I will see you on 17th December 2022. Thank you very much.